Okay, so what we're going to do today is we're going to talk about significant figures, and in order to do that, we're going to be looking at data and learning how to count them, and then we're going to learn how to do some operations with them. Okay, so significant figures, the reason that they're important in chemistry because it represents things that we measure, and those things have certain pieces of equipment, and some equipment is better than others. And so the number of digits you record in a piece of data tells the reader something about your equipment. And when we multiply and divide, and sometimes our calculators give us all these digits, we have to follow these rules in order to keep everything accurate. So this is a graduated cylinder. You probably have some experience using a graduated cylinder. We use these things for measurements. Syringes we don't use any needles. We're not in medical careers or anything like that. This is a burette. This is a better measuring device than a graduated cylinder. You may have used a beaker before. You know, a beaker is really not a great measuring piece of equipment. It's good for like rough estimates, but not nearly as good as a graduate cylinder or a burette. And the volumetric class you probably won't use. Pipettes we'll probably use. These are all better than a beaker. Okay, so they have different amounts of Sig Figs that go along with them. Okay, so here's our rules. Okay, so this is just set up to make it into a flip book. Okay, so if you want to do that flip book, you can pause the video right here. You take 3 pieces of paper and you stagger them about half an inch, a centimeter and a half apart from each other, and then you fold it over so you have 5 tabs, 6 tabs, 6 pages. The top one's going to be significant figures, then tab 1 is non-zeros and captives, tab 2 is zeros in the front, tab 3 is zeros in the back, tab 4 is operations, and tab 5 is scientific notation and Sig Figs. If you're just going over the Sig Figs, you can skip. And if you need more time, just go ahead and pause it. I think there's a picture of what the flip book looks like also in the folder where this video is. Okay, so one of the things that we need to deal with are numbers in different formats. Okay, so whenever we look at a number, okay, so it says all non-zero numbers are significant. So in this number, 79.3, anything that's not a zero by default has been measured. So we would say in this quantity right here, I have 3 Sig Figs. Okay. Any number that's not zero is a Sig Fig. It represents something that's been measured in the lab. Okay. The 1 and the 5 is a Sig Fig in this next number. And what about that 0? Okay. The trouble happens with the zeros. Sometimes they count, sometimes they don't. But zeros that are in between always count. So just by the fact that that 0 is in between a 1 and a 5 means that it's what we call a Sig Fig. Significant figure, it counts as a measured digit. Okay? And then in the next number, you'll notice that we don't really use commas in chemistry. Most of the time, you know, if you look in your textbook, it's got a gap like this. I think it's just because commas can be misconstrued as decimals, so they just don't do them. It's like extra work for chemists. So the 8 and the 3 and the 5 are going to count just by the fact that they're not a 0. So then the zeros in between those, because they're in between, means that this number has 5 Sig Figs. Okay, so I usually don't have people have problems with rule number 1. Non-zeros and zeros in between is pretty straightforward. Okay, so let's go to the next rule. Zeros in the front. Okay, so we call these placeholders. And with zeros in the front, they are never, and you don't get a lot of nevers in chemistry, so you want to celebrate that. They never count as Sig Figs. Okay, so we would go left to right, no, 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 and then I kind of mentally stop and go, oh, wait a minute, that's not 0. So in this value, I have 1 Sig Fig. And if I go to the next one, they don't start counting until I hit a number. No, 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 no. Oh, stop. Yes, 1 sig fig. Okay. Then if I look at the third one, no, 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 no. Oh, yes, this one counts. And of course an 8 and a 1 count. So this would be 3 sig figs. Okay. Now these rules end up mixing together. Okay, so I could have something like this. Okay, where no, they don't count. Okay, now the 1 counts. The 7 counts. What about these guys in between? Yeah, they count because they're in the middle. So this would be 4 sig figs. Okay. Rules 1 and 2, page 1 and 2, usually everybody's pretty straightforward. I'm okay with that. Okay, stop the video if you need more time to write down, but I'm going to go ahead and go. Now, this is the rule, this is the deal breaker right here, the zeros in the back. And I call them trailing zeros sometimes, because sometimes they count, sometimes they don't. Okay, and then the key is really right here. Do they have a decimal somewhere in the number? If they have a decimal somewhere in the number, chances are they're going to count. Okay, so the 1 is going to count no matter what. The zeros at the end, they count because there's a decimal. Okay, then what about these guys in the middle? Well, this goes back to rule number 1. So I'd say yes, everybody here counts as a measured number. So 1, 2, 3, 4, 5, 6. 6 sig figs. And so this is the thing. We are going to be using our calculators. And calculators are great tools. They do operations very quickly, but they don't know sig figs. And you really have to be the brains of the operation. You have to know the sig figs and know where to round. Because if you take this number and put it in your calculator's going to drop those zeros. Because quantity-wise, it's no different. But if we have those zeros in chemistry, it means that we know, as a matter of fact, there's no pennies, no nickels, no dimes laying around anywhere. Okay, so those zeros are representative of that. And then the zeros in between, they count because they're in between. Okay, so let's look at this next one. Never are these going to count in the front. Doesn't matter if there's a decimal. Rule number 2. Yes, yes, yes. Now what about this 0 here? One of the common sense things I think of this is like, why is that 0 there? Okay, because quantity-wise, it doesn't change the number. So if you think about it with common sense, it's there because it's been measured. And there's a decimal. That makes that 0 at the end count. So 1, 2, 3, 4. 4 sig figs. Okay, so we're going to practice this because it takes practice. It's like learning any other skill, riding a skateboard, learning how to snowboard. You need to practice. I can talk you through, but until you get on your own and do it, it's not going to stick. Okay, so now these numbers over on the other side, notice there's no decimal here. Okay, so the 1 counts, the 5 counts, the zeros in between count, but what about the 0 on the end? I don't have a decimal, which means it's an estimate. It's somewhere around 100,050. Okay, so we don't count that 0 at the end as being measured. So for counting sig figs, it's going to be 1, 2, 3, 4, 5. So this equals 5 sig figs. Okay, now look at this next one. 57,000. Okay, no decimal. So those zeros at the end, they don't count. The only thing that counts is the 5 and the 7. 57,000 would equal 2 sig figs. Now this number at the bottom, no decimal in sight, so the only thing that counts is that 1. 1 sig fig. Okay, now sometimes we want to make a number a sig fig, and it's not the way it's listed. So sometimes we'll use this indicated by a line. And so let's say you have 100 and you want it to be 3 sig figs. We can put a line over a 0, and that means we want that 0 to be a sig fig. We don't use it very often, and it's not the line you would put over a number for repeating decimal. In math we do that. In chemistry we don't care about repeating decimals. We care about how many places have been measured as data. Okay, so we're going to keep that on the back burners, and I'll show you when we start doing operations an example of when you would want to use that. All right. Okay, so now we're going to talk about operations, which we do more. But some of the homework I'm going to give you is going to be like how many sig figs here, how many sig figs there, getting used to counting them because that's kind of a prerequisite for doing operations with it. Okay, so this is multiplying and dividing. We do far more of this than we do adding and subtracting, but we do both. Okay, so if you look at the steps, it says do the operation. So at my calculator, I'm going to go 21.3 times 1.3, and so I get 27.69. So that's what I get for my answer, 27.69. Grams times grams, kind of a weird unit, it's going to be grams squared. Okay, so now it says round my answer to the least number of sig figs in the original problem. So when I look at 21.3, that's got 3 sig figs. 1.3's got 2. 2 is less than 3, so I'm going to round it to 2 sig figs, which is going to give me 28 grams squared. This 6 is going to round that 7 up, and then I can just drop that 9. Okay, so that's an example of how we would use this rule. When we get to the next one, 5 times 25 is 125. Centimeters times grams is just going to be centimeters dot grams. Okay, so it looks reasonable, and like I said, in math class you kind of go, okay, well, what's wrong with that? There's nothing wrong with that, right? 1 sig fig times 2 sig figs, which means I need to round this answer to 1 sig fig. Okay, so this is the thing. A lot of times people will go like this, but it's not the same quantity, okay? 125 versus 1 is just not the same. What we're saying is we need to round it to the nearest 100. Is it closer to 100 or 200? So 125 is closer to 100, so we're going to round it to 100. Seems like a lot of rounding, and we don't often round to 1 sig fig, but that's technically correct. Okay, so for the next one, 65.3 times 7.6. I get 496.28. Grams times milliliters, like that. So I've got 3 sig figs and I've got 2 sig figs. I want to round my answer to 2, okay? Which means I want this place and I want this place. So the 6 is going to round that baby up, okay? So we know that it's a 10, right? So when we round this up to 10, that rounds it to 500 grams dot milliliters. But we got a problem here because this is only 1 sig fig. So this is where we're going to use that little line and say, hey, I want that 0 to count as a sig fig. So we put a line over it. That means it's a sig fig in our class, and it means that I measured it, okay, and it's going to count as sig figs. Sometimes people don't dig that line over it, and so you would have to put it in scientific notation. I don't know why my tablet is doing that, but just ignore that line, like this. And we will be talking about scientific notation, but that's just an option for you. Okay, so let's look at this last one. 3.4 divided by 153. Okay, now when I get this in my calculator, it looks like a repeating decimal, right? It's going to go 2, 2, 2, 2, 2 forever and ever, and you could go like that in math class, and that would be correct. In science, we could care less about the repeating decimal. We want to know how many sig figs do you round your data to. So this has 2 sig figs. This one has 3. I'm going to round my answer to 2. Okay? Sometimes I get students that do this. Okay, but those are preceding zeros. They don't count as being significant. So that would really be no sig figs. So 2 sig figs would just mean I'm just going to write 2 of them down. Grams per milliliter. Okay? Now, it takes some practice. This is the beginning, okay? So once we first start doing it, we need to play around with it for some time and use it in different situations. So we are going to be using it in the lab, and we're going to be practicing doing our multiplication and division and adding and subtracting in the lab and practicing with numbers and applying it to our collected data, okay? Now, adding and subtracting is a little bit different. You still do the operation first, okay? But you might remember when you learned how to add and subtract in elementary school, it was all about the decimal place, okay? It still is all about the decimal place. Okay, so I get 31.195. when I add these guys up, centimeters, okay? So this is the thing. If I look at the rule says round your answer to the least number of decimal places in the original problem. So I've got 2 decimal places, 1, 1, 3 decimal places. Okay, so I'm going to round it down whichever one's the least, which is 1, round it to this place. So the 9 rounds that up. I get 31.2 centimeters. Okay, so each of the rules is good. It's not that bad, but when you get them all mixed up together, it does take some practice. And these can be put into multiple choice type questions like this. So when you look at this question and you're thinking, I'm in high school chemistry, 15 minus 2, right? There is one right answer, and 3 of them are wrong, according to Sig Figs. So I'm not giving you a calculator and saying, can you please minus 15 minus 2? That's ridiculous, right? Calculators are good for doing operations quickly. They do not know Sig Figs. Okay, so if we look at this rule, it says do the operation. So clearly this is going to be 13. Round your answer to the least number of Sig Figs in the original problem. So least number of, decimal places in the original problem. So there's 3 decimal places here. There's none here. So this would be the most rounding you would do in this situation. No decimal places. So the correct answer would be D. Okay? So the last page we're going to talk about is scientific notation. And I'm really just going to kind of review the rule real quickly because there will be another video dedicated to putting things in and out of scientific notation. Okay? But when you're looking at something in scientific notation, you're only going to look at the value in front of the times 10. So if you're writing this down, sorry, I don't know why it's doing this. Go ahead and pause it. But when you look at scientific notation, everything in front of the times 10 to whatever exponent is a sig fig. So 1, 2, 3, 4. So this would be 4 sig figs. 1, 2, 3, 4, 5 sig figs. This is 5 sig figs. Okay, and so the rub comes when we have to put it in and out of scientific notation. You have to keep it in the same number of sig figs. Okay, and infinite sig figs is going to be when we start doing conversions. They're equivalents, so like 1 meter equals 100 centimeters. It's an exact number. So I could put 1.00 behind any of these numbers. Infinity, forever and ever and ever, and they wouldn't end, and it would still be accurate. So for now, since we're just doing sig figs, I really don't want to focus too much on the infinite. I just wanted it to be a complete lesson so you have all that information. All right, this is going to be a wrap on sig figs.